software project called G#, which I actually named before Microsoft named C#. So I guess I'm going to have to change it because people otherwise associated with that. It's a project to write an interactive editor for musical scores. Formatting musical scores is much more difficult than formatting text because standard music notation is quite arbitrary. Actually, it's a collection of kludges that have sort of become the standard over the past couple hundred years. It's also more complicated than text because it's essentially two-dimensional. You have a horizontal time aspect, and then you have multiple voices going on in parallel, and they have to be formatted simultaneously and aligned properly. So that's a difficult problem. The other problem is that whereas in text, you can always limit the kind of reformatting that you need to do. Usually, for instance, paragraphs are reserved independently, and you also have chapters that mark new pages that kind of make formatting sort of not necessary to redo for the entire document if you have text. But for music, you have a small minor change can have global consequences on the entire document. Another reason for that is that a musical score, usually the tradition is to fill up the last page from top to bottom so that you can't have the text stop or the musical material stop in the middle of the page. You can also have interesting constraints such as it has to fit exactly on 4 pages because you sell those piano sheets that are one A, 3-page folded over. So you can't just stop in the middle or spill over when things get crowded. And the other thing is that music has, of course, semantics. It means something. You can use it to play from. But there's not a clear separation between what's notation and what's semantics. So if you look at many musical scores by great masters, you in fact find that the notation does not respect the traditional semantics of what you would expect, like the duration doesn't correspond to what it's supposed to be, and the duration of a measure, for instance, doesn't correspond to what's actually notated. There's some very interesting conflicts. So in fact, it's not clear how to interact with an interactive score editor. Existing editors propose different user models. I'm not going to go into that simply because I don't know very much about existing editors. I belong to a group which collaborates with composers in a computer music group. So I trust them to tell me how things work. Some of these models often have many inconveniences. Either they let you notate everything you want and you don't get any semantics behind there, or else they impose semantics that makes it impossible to notate certain pieces. So, for instance, when interviewing potential users, I get what kind of functionality they would like to see. I've actually gotten the entire spectrum of answers. One person suggested that I put up a bar of musical characters, essentially, that you would click on and drag and position on your stage. And I told that person, well, would you be happy if I wrote you a word processor in which I displayed all the characters and you could place them manually, pixel by pixel, in words? And that person then realized that might not be exactly the kind of interaction that you want from the score editor. And on the opposite end, usually from musicians, they say, well, it's obvious that you should have the user pick a particular duration or a particular rhythm, and then the editor should verify that that rhythm is respected, except that great scores from great masters don't respect that, and it kind of that would prevent you from notating certain conventional musical pieces that are masterpieces, but that are not notated according to the semantics. So the truth is somewhere in between those two, and I just don't know exactly quite yet where. So this project is partially to figure out what kind of interaction one would want with a musical score editor. So there are many reasons for starting this project. When interviewing my composers, they were usually dissatisfied with what they have, and mostly those are users of Finale. It was hard for them to explain why they were dissatisfied, because they could usually get the job done, but I could tell by the way they were interacting with their software why they were dissatisfied. A thing like Finale is usually is a collection of tools, and each tool most likely was written by a different programmer, so it works slightly differently from every other tool. And every time you have to do a minor editing job, you essentially need to call up a tool and make that tool do what it is that you want. There's not a real coherent way of interacting with the editor. Another reason for starting this project was that it was a research challenge. I wanted to design an editor so that an incremental change to the score could be taken into account at user typing speed. So I essentially have an algorithm that can reformat a score that has several hundred pages at typing speed, so 100 milliseconds or so. And it was a programming challenge. Like I told you, I'm a teacher of computer science, but and I like to teach programming courses. But in order to teach programming courses, you sort of have to program from time to time. And this was an excellent excuse for me to have a project that might be actually useful one day, and that might provide me with some exercise in programming. Also, I should actually add a few reasons for starting the project here. I started teaching Common Lisp a couple of years ago, maybe 3 or 4 years ago. And there's some questions I'd rather not get into discussions with students about, such as what applications are Common Lisp used for, and how many companies actually use it, and these questions are really tough to answer. So I wanted to have one of those killer apps that I could point to and say, hey, this is one. Okay? And the most natural thing for me to do was to start writing. Well, killer app, I guess there's a limited fraction of the population is into score editing, but still. If we look at the development history, the first version was done by a group of students in Pickle TK around 1995, which was essentially just a way of determining what the right interaction model was. And it was a very interesting experiment because we realized how essentially we got everything wrong. And the second version I wrote myself, which was in Guile in 1996. But it turns out that at the time, well, Guile was too slow for the algorithms that I needed it for. And I found myself writing a lot of C code, and that sort of defeated the purpose, I thought. And also, Guile turned out to be really hard to track. Like every time I updated my Guile, then I broke my application. So I kind of got tired of trying to keep up with modifications of Guile. So I wrote a third version around 2000, which used Common Lisp plus CLX. This was roughly at the same time I started teaching Common Lisp as opposed to some other languages at the university. It worked fine, and actually that version was the last version that is not vaporware. The current version, unfortunately, is, so I can't give you a demo today. I used CLX pretty much directly. So that took care of the real-time display of the score itself. But it made it real hard to use things like menus and buttons because I would have to write them myself. CLX doesn't supply that. So that's when I started looking for a GUI library for G#. So I decided to put that on hold and write Klim first. And for those of you who attended Tim Moore's talk, that's essentially what happened. It took essentially a year and a half, 2 years for Klim to happen. And now it's pretty much up to standard. So I'm happy to say that whenever I update with a new version of Klim now, nothing breaks, which is good news. So the fourth version of G# is actually being worked on, and we tried real hard to get it up to demo quality for this conference, but we unfortunately failed. So you're going to have to wait until the end of the year to see a demo of it. So if you look at the end user requirements that I set for G#, like I told you, I wanted to have page layout in real time of a score with potentially hundreds of pages. So I want to be able to lay out a complete score of hundreds of pages in about 100 milliseconds, which I know that I can do now. I wanted it to be extensible in the spirit of Emacs. I wanted to have keyboard macros and complete subsystems. I wanted people to be able to load their favorite code of how to do the page-breaking algorithms and stuff like that. I wanted to be able to render the score. Of course, the normal rendering of the score would be in the form of traditional music notation, but I also wanted enough semantics that you could click on, listen to this, and actually get a MIDI rendering that wouldn't be too bad. I wanted to respect the rules of music engraving. I have seen many score editors that are made by people who have absolutely no clue about music engraving. So the spacing is not what music engravers traditionally do. So I read up on music engraving and several existing projects like the line editor, which doesn't do automatic line breaking, but it does have a spacing algorithm that conforms to tradition. And I read up on books like Ted Roth's How to Teach Yourself Music Engraving. So I would have a good idea of how to actually do it. And I wanted it to be a tool for musicians and engravers at the same time. A musician usually doesn't know actually anything about formatting scores. It's really interesting. They know how to read one, but they don't know how to produce one. They don't know about the spacing rules. They don't know about beam slants. They don't know essentially about anything. So I want it to be a tool that can be used by a musician that doesn't have any clue about those rules, but I also want it to be a tool for an engraver who pretty often would like to tweak the layout of the score. And of course, the standard stuff, I wanted it to be multi-buffer, multi-window. I wanted, like I said, the layout algorithms to be possible to replace or having a choice being given to the user as to which layout algorithm would be used. When I say that layout algorithm, that would be typically things like, well, how how much space you would allow in the score, but also the fact that I wanted to fill the last page, or I want an even number of pages, or I want the number of pages to be a multiple of 16 or something like that. I wanted that kind of algorithm to be possible for all of them. And I wanted this acceptable user model compatible with other requirements. I wanted a user model. I want the user to think about what is actually being modified in a way that I could implement, but that would not be too bad as far as the user is concerned. And I wanted paper out to closely resemble screen output. Internally, of course, I wanted maintainable and reusable internal architecture. I wanted it to be easy to write extensions so that ultimately I could write an extension writer's guide and have people who didn't necessarily know about the internals of the software to be able to write useful extensions to it. And clean internal protocols, of course, so that it could be cleanly documented. That essentially requires an Emacs-like redisplay algorithm that essentially the user-visible abstract data structure doesn't know about. So the user should edit this abstract data type, and after each user interaction, redisplay should be invoked to correctly present the score. So it turns out you can do that in 2 parts, luckily for me, because otherwise I wouldn't be able to meet the requirements. The first part being dividing the measures up into lines and pages. And that doesn't require any complete knowledge of exactly where on the page you place each musical character. And then only the pages that are actually on display, typically 1 or 2, would be necessary to render very precisely with the exact right spacing between each character. So one important thing, too, would be to have Emacs-like keyboard macros so that the layout algorithm wouldn't be executed after each modification of the abstract data type, but only after each complete user interaction, so that if a macro is executed, potentially a large part of the score would need to be reformatted. And so, yeah, and to allow for users to write extensions, then extension code should not mention essentially how this is displayed. It should just be modifications to the user visible data structure. I'm not going to talk about what the user visible data structure is like. It's fairly complicated, and it uses names that are not standard in music because they roughly correspond to some musical concepts such as phrases and voices and so forth, but not exactly. So I didn't want to call them phrase and voice because it would give them wrong associations. But it's a data structure that has roughly five different layers. The highest of one is buffer, and then you have the musical phrase and a voice and so forth. I am going to talk a little bit about the page breaking algorithm, which is probably the most important part of the system. And without this algorithm, actually the entire project would be wasted. So the problem can be reduced to breaking a sequence of objects, which here would be, each object would be a measure, into subsequences in an optimal way. So you take a sequence of objects and you just want to break it in some optimal way. And of course, then it means, it depends on what you mean by optimal. And what we're going to do here is to say, well, each subsequence has a cost associated with it. And that cost depends on, of course, each individual component and an abstract way of combining costs of the individual components. As it turns out, in music, the components are going to be measures, and the sequence, basic sequence is going to be a line of measures. And the cost of the sequence of those measures actually depends on, in subtle ways, on what kind of notes there are in the other measures. So I wanted to abstract all that out and say, well, it's just a sequence of objects, and I have a cost function associated with that. I have a way of combining costs for a sequence and an object added to the end of the sequence and so forth. And then I have another cost function that says, well, given that I have two subsequences or more subsequences in the entire score, what is the cost of it? And currently I'm using essentially a minimax kind of optimization where I say, well, I minimize the maximum cost of each line of music type. Well, that turns out to be a dynamic programming problem. I'm not going to go into what dynamic programming means here, but essentially means you compute the cost of each possible page break. You say, what if I cut here? What would the cost be? And then you say, what if I cut here then? And then what would the cost be? And this way, you sort of compute all possible page breaks, and then you just pick the best one. That will be your optimal subsequence. Well, the dynamic programming is, in this written like this for this particular application, would require an O(n) squared algorithm. And by observing some elementary restrictions, such as, well, if you add a sufficient number of measures into a page, the cost will just increase after a certain time. If you make that kind of observation, you can get it down to linear time. That's still not good enough, so I designed an incremental algorithm to make this O(1) in most cases. In most cases, it means it's essentially the same as for something like Emacs, that if you work locally, then it's going to be constant time. If you write a macro that goes to the beginning and deletes some stuff, and then to the end and inserts some stuff, then yes, it will be linear time. So to continue this page breaking algorithm, I told you that it essentially computes the cost of each possible page break. The first observation is this kind of algorithm gives the same result if you compute from the beginning or from the end of the score, or from the end of the sequence. So the solution to make this incremental is to say, well, let's hope that the user works at the same insertion point roughly, and to compute the score from the end and from the beginning to that point. That means that essentially all the computations that are done from the beginning to that insertion point, from the end to that insertion point, will not have to be redone when there's a modification. All that we need is a kind of overlap zone that computes the cost for a certain number of page breaks both from the beginning and from the end of the score. And if using minimax, that means that the cost of the total score would be the max of those two costs. So it's sufficient to scan this particular small zone around the insertion point and pick the best page breaking cost, and that will determine the optimal score for the entire several hundred pages. So that's why I made it incremental. So that's illustrated here. So here,
borrow a laser pointer?
sure. So when we start this off, this is supposed to be measures here. When we start the software, we'll say, okay, let me compute the cost of what it would cost for me to, should I put a page break here. And it'll compute a cost and also the position of the previous page break. And then I do the same thing here and I say, the optimal page break will be here and at the beginning at a certain cost. Well, where I'm supposed to break here, I will have those 3 measures in the first page. And where I break here, I would actually have another page break here and another page break here. So that'll be a 2 pages would be optimal for that. And so forth. That's just traditional dynamic programming. The trick here is I do the same thing from the end. Okay, and insertion point, the user is going to be working somewhere in the zone here. And what remains to do after this computation is done is to compare the max cost of the cost from the end, from the beginning of this page break to the max of the cost from the end, from the beginning of this page break and this page break. And a certain number of those in a zone that has to be a little more than a page wide. And once I pick the best one, then I have the entire page break for the entire score computed from the beginning and from the end. There's a small issue of whether this solution is unique, but I'm not going to go into that. So is that clear roughly how that works? So when the user inserts something here, and everything that was done from the end and everything that was done from the beginning is still valid. So mostly this calculation would be incremental. So a little bit about the internal architecture. I use CLOS and MOP in order to completely isolate the abstract user visible data structure from the display code and the page layout code. And we actually go in and Gilbert Bauman helped me with that. Go in and alter the inheritance list of certain classes and user visible data structure. And I also use CLOS in order to have a clean separation between the page breaking algorithm here, which is kind of generic, and the combined cost functions that will tell me what would the cost be of a subsequence with another object attached to the end or to the beginning. Those issues I wanted separate so that new page breaking algorithms could be tested separately from new cost functions. Use CLIM to separate, of course, user interface from the internal data structures. And those who listen to Tim's talk, that should be pretty obvious how that's done. And at the moment, we don't use presentation types quite yet, but you can easily see how that would be a win in order to have presentation types associated with various musical objects that the user can click on and interact with. The near future of the project, like I said, unfortunately I don't have a demo for you today. But I do have a full-time developer who's going to work until the end of the year. And so we hope to have a fairly good prototype at the end of the year with every functionality. Somewhat further in the future, which means we know how to do it. It either worked in the CLX version, or we've had other implementations that show how to do it. Multi-stage systems, that's not a problem. We know how to do that. Multi-buffer, multi-window is not a problem. The beaming algorithm is complicated but straightforward, and so I know how to do that. The final spacing between each chord essentially needs to be slightly improved, but we know how to do that too. If we look a little bit further, there's some things we don't yet know how to do. We don't know how to put multiple page layout styles in a clean way in the current software, like a model with a paper roll, say, where there's no page breaks but only line breaks, or this multiple of 16 thing I don't know how to do in an efficient way yet. The vertical layout is kind of tricky. The most straightforward way to do is to say each line of each system takes a certain amount of space, or the spacing between two systems is fixed. But if you do that, you might actually have overlapping musical material from two different systems. One that goes way below the lowest stack of the first one, and the other one going way above the upper stack of the other one. So a really good system would take that into account and add spacing to it, or even reorganize slightly the musical material of each system so that they wouldn't clash. That's very likely a very hard problem. I don't know how to do that. Advanced tweaking of layout decisions, like you would want to put in hints and say, it would be advantageous to cut the page here because the pianist is only using one hand, or the clarinetist needs to breathe, or something like that. And so you want to put in this kind of hint that the page breaking algorithm should try to observe. You don't know how to do that. Arbitrary postscript figures in score. At some point, you're going to have to attach arbitrary postscript material to musical material, because that's what composers do. They annotate things, and they want their annotations to be kind of freely drawn. And we don't know how to do that either. So to conclude, I think Common Lisp is an ideal language for this kind of end-user application. I think we need this kind of applications to show that Common Lisp is a good thing. Such an application, I think, is a very nice vehicle for experimenting with programming techniques. I mean, I only got into Common Lisp a couple of years ago, and I needed a couple of vehicles for learning how to do that. And G# is one of them, and McClellan turned out to be another one. It just becomes useful to somebody without a technical background. That's great. If it doesn't, I'm not going to be that disappointed, right? Because I'm having a lot of fun. The only thing perhaps is my experience is, don't let users get involved too early in this kind of stuff. If you ask a user what he or she wants in terms of functionality, they're always going to want exactly what they have, whether it's good or bad. One musician who actually turned out to be also a programming student of computer science, he told me that it was a completely ridiculous idea to format the score after each user interaction, and that I should have a button that says, now format. And I told him, well, what if I told you I'd give you back Word, Microsoft Word, where you no longer automatically format the paragraphs, and you sort of just spill over and you have to click and say format now. And it's the same issue essentially, people driving stick shift cars, which is a limitation of the combustion engine, right? Even if you put an electric motor in there that doesn't need the stick shift, people are going to say, oh, I want my stick shift, because they're so used to the limitations that they can't possibly imagine a better way of interacting with their tools. So you have to at some point get users involved. But I recommend that you first try to think really hard yourself about how you would want to do this. And then at the end, see what the users say and see whether interaction is reasonable. Thank you very much. Actually, that's it without stage, right? Actually running the thing.
Like John Cage's silence.
Exactly. Any questions? Yes.
As you were talking, I kept being reminded of the problems that came up with text formatting. I know you said it's one of the problems, but there are a lot of issues that were addressed, for example, with Strandh's text system. And I'm wondering, in the history of document processing, there were sort of two schools of thought. One was present the user with what they want and then worry about making it look good at the end. And then there was the technical, which was make sure it looks good and then figure out what the user has to do.
Yeah, this is the tech approach.
So, do you think there's many analogies?
Yeah, I think there are quite a lot of analogies actually. I think a lot of the software that you see today essentially doesn't know anything about music engraving the way Word doesn't know about text formatting. And I think that's sad. I think we should aim for equality, but I realize I'm a very odd person these days in that respect.
Related to the front end is what about the back end? Text spends lots of time in fonts. So like the device drivers and things like this.
Okay.
Is that an issue?
Well, yeah, I actually got into that mess, and I'm trying to get out of it by using the CMN fonts, Common Music Notation. So that's what we're going to put in now from now until the end of the year. So that's going to be directly in PostScript, and we're going to have to write some Mclim extensions to render those fonts efficiently. But the good thing would be they'd be automatically scalable, and you can directly make PostScript output from them. So, you have a question back there, Nelson? Yeah.
Yes. Did I understand that you said that you used mop to dynamically modify the inheritance in your system?
Yeah.
Can you say a little bit more about why you found that helpful and what you're doing there?
Well, the trick is you want to, for software engineering reasons, you want to have as little possible mention of layout stuff in the user visible data structure. And so, for instance, if the redisplay algorithm needs an additional slot in that data structure, you can't possibly put it in. And you can't either derive from those classes, because then they won't be of their original type, and you would have some weird, well, actually, it's a problem just to create instances of those classes afterwards without mentioning that there exist another one. So we dynamically go in and add mix-ins to those classes, and so the redisplay code adds whatever it thinks it needs to the user visible data structure in order to keep track of various things and make sure it knows the order of measures and that kind of ilk.
Is this a technique you discussed with your students in your class?
No.
Yeah, it seems like the spacing problem gets really interesting when you allow the user to add bottom-up constraints, saying, in this system I want exactly 2 measures here, and then publication constraints would say, I need this to fit on 4 pages exactly, or I need this to fit on some subset of 4 pages.
Yeah.
And I'm wondering whether the spacing problem really becomes unspecified or
Yeah.
well,
there might not be any solutions to that.
specified as you begin to add constraints from both ends.
There might not be any solutions to that. So at the moment, we don't add enough constraints, or the constraints that we allow, we know we can find a solution for. And it's a very delicate thing then to give some of that freedom back to the end user without making it possible for there not to be any solutions to or that give the performance.
In a practical typesetting situation, a user might relax some of the bottom-up constraints in order to fit a hard boundary of 4 pages, or might decide, because of some irrevocable constraints at the bottom, this is going to have to fit on 5 pages.
Yeah.
And so
That's all kinds of that problem, and all combinations of those. Yeah. And, the truth is, I don't know how to handle the general problem. So, yeah, it's very, very complicated. Yeah.
I was a little surprised by your comment about don't let users get involved, don't let them ability to put in page breaks on their own and so on. That's counter to my experience as a user. People tend to want that control even if it makes it worse, so they can try out alternatives. I think the case of photo speed and software like that, where you got one button enhance the picture, you click it, it sort of adjusts contrast, brightness, hue, all at the same time, and that usually does it. But you always want to go ahead and read down the guys and all those. And even if it becomes worse, just having that option makes you feel more comfortable with the tool.
That might be, but I also think that's something that changes over time. Like once a user gets used to a certain kind of interaction mode, they kind of tend to forget about what they initially wanted. So my bet is that I'm going to be able to expose my composers and my musicians to this and have them forget about that button eventually and just like the way it's done. But I, of course, can't guarantee that that's going to be the case. Thank you.